Principles of Bioproduct Separation Module 2, Filtration and Microfiltration Segment 2, with me again, Yusuf from Institute Teknologi Bandung. Previously, we have discussed about the equipment for filtration. In this segment, we will discuss about pre-treatment in filtration. Pre-treatment is important because separation of fermentation beers is difficult due to high non-Newtonian viscosity of highly compressible cakes. These cakes can deform into an impermeable mat and consequently often require pre-treatment. There are three major pre-treatment methods that can be applied in filtration. First is heating, second is coagulation and flocculation, and third, adsorption on filter reeds. The simplest pre-treatment and the least expensive is to heat the feed. Heating may improve feed's handling characteristic and also may pasteurize the feed. The chief constraint of this approach is the thermal stability of the product. Heating is effective, but one must be careful so that the biological solids, particularly protein, is not irreversibly altered. A second pre-treatment is the addition of electrolytes to promote coagulation and flocculation in the initial solution. Useful agents include simple electrolytes such as acids and bases that act by screening the electrostatic repulsion which commonly exists between colloidal particles. When this electrostatic repulsion is reduced, attractive London van der Waals forces predominate. The colloids can then coagulate as larger, denser particles which are more easily filtered. Synthetic polyelectrolytes added can both reduce electrostatic repulsion and adsorb on adjacent particles, forming bridges between them. Consequently, the colloidal particles flocculate as large, less dense aggregates which are more easily filtered. Polyelectrolytes can be anionic, cationic, or non-ionic, such as polyacrylamides, polyamine derivatives, and many others. The third method is the addition of solid filtrate to the solution prior to filtrations. Colloids in the solution adsorb on particles of filtrates, which solve two chief problems in filtration prior to the filtration itself. First, compressibility of accumulated biomass, which reduces permeability. Filtrate helps to form less compressible cake. Second problem is penetration of small particles. Filtrate helps to reduce penetration of small particles that can block the filter medium. This figure shows the effect of pH on filtrate volumes of fermentation broth. It can be clearly seen that lowering pH accelerates filtration. Whereas this figure shows the effect of filter rate on filtrate volumes of a fermentation broth. It can be clearly seen that increasing concentration of filtrates accelerates filtration. Two types of filtrates that are commonly used and effective for pretreatments are diatomaceous earth and perlites. Diatomaceous earth are skeletal remains of tiny aquatic plants deposited for centuries, whereas perlites are volcanic rock processed to yield an expanded form. Important properties that must be considered when choosing a filtrate are density, pH, water adsorption, and relative flow rate, with each filter had specific property that differs from others. This table shows typical application of different filter rates as well as expected relative and visual clarity, including production of beer, petroleum products, antibiotics, fruit juices, and many others. Hence, selection of suitable filter rates depends on their properties and field of application. For the next segment, we will discuss about general theory of filtration. Until then, I am Yusuf from Institute Teknologi Bandung.